or decrease in the speed of a moving object or sometimes stops it.
Okay.
It can
So
lead to
the
noise pollution in certain cases. For instance, aircrafts produce loud sound due to the resistance of the air.
okay. So talking about this one disadvantages of friction, there are numerous disadvantages of friction. Some of the disadvantages we already discussed in the previous class, right? Like it results in wear and tear of different objects. Right now, as the different parts of the machines would develop friction between them, so due to friction, heat will be generated, and due to that, the parts of the machine can get broken, or the tires of the vehicle or the sole of the shoes that will be kind of going through wear and tear, so they will be getting damaged. Okay, it results in the production of heat. So in the case of machines, production of heat leads to wastage of energy. Right now, so lots of energy will be wasted in that. Also due to heat, the parts of the machine might get broken. Also the fuel consumption will increase. Right now, the fuel consumption will also increase. So fuel consumption increases, right? Also, if the parts of the machine are going through friction, so thereby efficiency of the machine will be reduced right now. Furthermore, it can lead to noise pollution also, right? It will lead to noise pollution. For example, aircrafts produces loud sound due to the resistance of the air. Due to the resistance of the air. Like you all would have observed or like would be aware of the concept of sonic boom produced by jet aircrafts. Uh, you guys know about this, like sonic boom is loud sound produced when an jet aircraft reaches the speed more than that of sound. Hmm? Getting it what I'm trying to say. So what happens now? See, there's a jet aircraft, for example. This is a jet aircraft, for example.
Oh, sir.
Yes.
Do you mean it breaks the sound barrier?
Do we have any breaks? Repeat again. Do we have any?
No, I mean, do you mean it when the jet breaks the sound barrier?
Yeah, that's what I'm trying to explain over here. That is called a sonic boom. Okay, now. See what happens when this jet aircraft would be flying. Now, it would be having a speed close of or more than the speed of sound. Okay, now you know that the speed of sound in air is about 340 meter per second. Right now, 340 or 343 meter per second. The speed of sound in air is 343 meter per second, around that. Okay, now it will be different in solid and liquid. In air, this is the magnitude of sound. Okay, so when a jet aircraft will be flying now, so it generates shock waves. So when a jet aircraft would be flying at supersonic speeds. So the concept is then, what is supersonic speed? So supersonic speeds are like if an object would be traveling faster than the speed of the sound, then that will be called as supersonic speed. Getting it, guys? So jet aircraft flies at supersonic speed. Is this thing clear to everyone? What is supersonic speed? Any object
Yes,
that will be
sir.
moving with a speed more than that of sound will be said to have a supersonic speed. Right now. Okay, now talking about the aircraft, right? So aircraft would be moving at supersonic speed. So thereby what happens now, as it would be moving through the air, so lots of air molecules would accumulate right now. So lots of air molecules would be accumulating in front of the jet aircraft. Eventually there will come a time when lots of pressure will be accumulated. Okay, now lots of air pressure will be accumulated in front of the jet aircraft. Okay, and it is because of development of that pressure, the molecules of air would be colliding with each other, which produces a high sound, which produces a loud sound that is called as sonic boom. Is the concept clear to everyone?
Yes, sir.
Okay, now, so you would have seen so many aircraft like, for example, F-16 aircrafts. They would be traveling at supersonic speed and will create a sonic boom. Okay, now, usually the pilots, the person flying the aircraft, they will not hear anything at all. Okay, now, because if they were to hear the sonic boom, so it will be problematic for them. Alif, you got this? Chakrika, Gauri, and Khadija.
Yes, sir.
Okay, now, just allow me to share just one image of it. For some of you, like if you haven't seen it. Oh, not this. See this image? This is the image of a sonic boom created when a aircraft would be flying at a speed more than the speed of the sound. That is how a sonic boom will look like. So aircraft will also produce sound, and this sound will be considered as noise pollution. Getting it? So why it is doing so? Because of the friction generated between the air molecule and the aircraft. So that is another disadvantage of frictional force. Hope you guys have understood this. Next, have a look at this image also. So basically it's a summary of some of the disadvantages. Like it can lead to forest fire also, causes noise pollution, wear and tear of different materials, and much more energy will be required for movement of the body. Now, another concept we are going to learn about, how can we reduce or increase the friction? Okay, now how can we reduce or increase the friction? So first you'd be learning about increasing the friction. Okay, now increasing the friction. Okay, so you guys tell me about this concept, how we can do so. Yes, how can we increase the friction?
By making the surface rougher.
Rougher, making the surface rougher, good. Or remember, just remember the different factors that determines the amount of friction. The amount of friction generated between two objects depends upon the roughness, depends upon the surface area that is in contact. Remember, we learned that in the previous classes. And with the magnitude of force also, that also determines the friction generated between the object. Now, getting it, guys? Or for example, you can, if there is some lubricant between the surface, some lubricating material, okay, now like oil or grease, so by removing lubricants also we can increase the friction, right? Now, or for example, instead of sliding friction, we can prefer rolling friction, right? Now, because in rolling frictions, friction is friction is less. Getting this, guys? So what are the things I have told just now? List down the important things as I told. Yes, go on. Yes, Chakrika, Alif. Guys, am I not audible to you?
Yes.
I'm audible, no? Okay. So what are the ways we have discussed right now? The first was to increase the roughness. So increase the roughness of the surface of the objects that are in contact, and
So by sliding it instead of rolling it?
by, repeat again?
By sliding it instead of rolling it?
Yeah, by sliding it instead of rolling the object. Very good. Right now. So by sliding instead of rolling, okay. By sliding instead of rolling. Because you know, sliding friction is more than the rolling friction. Good. Also in this image, look at the patterns that are made on the tires or on the soles of the shoes. So it is in order to increase the roughness of the surface so that friction increases and thereby grip will increase. So it will be easier for the vehicle or for us to walk, to move on the road. Okay, and what else? Yes. Say if there are some lubricating materials between the surface of the two objects like oil or grease. So by removing the lubricating material, we can reduce the friction right now. So by removing lubricating materials. And what else? What are the other ways? Remember, weight of the object also determines the friction now. Heavier the
Yes,
weight,
sir.
more will be the friction. So by increasing the weight. Okay, now by increasing the weight. By
So the area of the object of the area in contact.
very good. By increasing area of contact. By increasing area of contact. Yes.
I have a doubt.
Yeah, sure.
Sir,
Go on.
is increasing the friction is good or bad?
Increasing the friction in certain case, it depends upon the situation where you are going to apply it. Okay, now, like for example, say we are increasing the friction in a bicycle or in a motorbike. Huh? So they are, by increasing the friction, the efficiency of the vehicle will be reduced, more effort will be required, more energy will be consumed to move that vehicle. So they are increasing the friction is disadvantages. It is not good right now. But when we by like when we increase the friction by making the sole of the shoes rougher, by making patterns on it, so their friction is advantageous. So it depends upon situation. At one place it can be advantageous, at another place it can be disadvantageous. So it really depends upon the situation. Okay, now.
Okay, sir.
Mhm. So these are the different ways via which friction can be increased right now. So hope you guys have understood this. Okay. Also, there was one more thing. Remember, we learned that the amount of pressure, the force that we apply, that also determines the friction generated. Right now, if you press two objects with a higher force, so more friction will be generated. Getting it? What I'm trying to say. Or when you are trying to move an object with greater amount of force, so more friction will be generated. So by increasing the force also, okay, now by increasing the force also in this manner, try to understand it in this manner. Like there are two objects placed one over another, object A and object B. So if you are pressing this object with a magnitude of, let us say, 15 Newton, so friction will be generated between the surface of two objects now. The friction will be generated. Getting it? Now in another situation, you increase the magnitude of the force and now you are pressing it with the magnitude of 30 Newton. So obviously in the second case, the friction generated will be more. Getting it, all of you? So when we press the two surfaces of two objects harder, so thereby in that case also friction is going to increase. Okay, now? And in real life, what are the situations in which we have to, in which increasing the friction helps? Huh? Like two of them is already mentioned over here. Like this vehicle where the tires are patterns are made on the tires to make it rougher, right now, so that it can easily walk on the road, easily move on the road. Getting it? The soles of the shoes, they are made rougher. Getting it now? Also you would have seen like a kabaddi player or karate players, not the karate players, I would say, particularly the athletes right now. For example, a javelin thrower, hmm, different kind of gymnasts. So they would they would be rubbing their hand with some rough material, with some coarse materials. Like they can rub their hand with some powder, some sand in order to increase the friction. in order to increase their grip. So there also increasing the friction is helpful. Getting it, all of you? So those are some real life situations where increase of friction can be helpful. Okay, now let us understand how we can reduce the friction. You guys first of all answer this. What are the different ways? What are the different ways using which we can reduce the friction?
Sir, ball bearing.
Okay, basically the
Sir,
concept of
lubricating
rolling
objects.
friction, lubricating the objects. Okay, and you guys have played carom? Anyone who have played carom?
Yes, sir.
Okay, so why do you sprinkle powder on the carom board?
To make it smoother.
To make it smoother or to basically reduce the friction, right now? Okay, so basically powder is acting as a lubricant there. You drive some vehicle, so after like you have to done the servicing has to be done on a regular basis, right? Now in servicing, oil will be put into the different parts of the machine, right? Like the one that you see here, oil is being put into the chain of this motorbike in order to reduce the friction. Getting it now? Because friction generates heat, and due to that objects will break. Okay, so by lubrication also it can be done. Okay, and by ball bearings, one of you were saying, by using ball bearings also, right? Now as you can see over here, these ball bearings, these are kind of small metal balls that have been placed between two circular objects, right? Now so when the machine will be rotating, when these machines will rotate, so these balls will also rotate, right? Now and they will reduce the friction. So what kind of friction will be taking place over here? Is it the rolling friction or the sliding friction?
Rolling friction.
Of course, rolling friction. And the friction is reduced. In rolling friction, friction is reduced right now. Okay, that is one thing. Furthermore, by polishing the surface of two objects also, we can reduce the friction. Like if surfaces of two objects are coarse like this, are rough like this, so by polishing them, we can make them smoother. So in that case, the interlocking effect between the surface of the objects will be reduced, right? Now hence polishing is also one of the method. Got this, everyone? So there are various methods. Okay, now or you can see over here what is happening in the second image. We're using a sandpaper in order to smoothen the surface of the wood, right? Now so basically it is polishing the surface. So various methods include by use of lubricants. Okay, now there are different kind of lubricants are there. Okay, now can you guys quote some examples of lubricants?
Sir, oil.
Oil. Okay, oil can be used like the one that you see. Oil can be put into the parts of the machine, and
So please.
grease can be used. Very good. Actually, you guys tell me this thing, like isn't grease a petrochemical? Hmm? Grease, isn't it a petrochemical? One of the product obtained from refining of the petroleum. You guys getting my question? I'm saying that isn't grease a petrochemical? Yes. Remember, there were different products, like in the chapter coal and petroleum, we have learned about that. Different products are obtained when we purify the petroleum. So one of them is grease also. Okay, now. Furthermore, you guys tell me, like there are certain machines where it is not possible to put the liquid lubricants. So there, what kind of lubricants has to be used? Yes, you guys know, like graphite is also used as a lubricant. Okay, no, graphite powder, it is very smooth and it can be used as a lubricant. Getting it, guys? So it is used in industrial purposes. Particularly, graphite will be um, used in those machine parts now where we can't use the liquid lubricants. Getting it? So graphite powder, that is also used. Okay. Another thing we learned, that shifting to rolling friction. Shifting to rolling friction. We have the examples of wheels, ball bearings, etc. Okay, na? By the way, let us learn about this for a moment, how the ball bearings work over here. Okay, na? Like how the wheels and the ball bearings would be reducing the friction. Okay. So as in this image, you can see that, as we know that whenever one object would be rolling over another object, the area in contact is less. An object that is rolling over another object, the area of contact is very less. Instead, if it were to be slide, or instead if it were to be the case of a sliding friction, so there we see that the area of contact is much more, so thereby the friction is more in that case. That is a rolling friction, that is so sliding friction, not a static, sliding friction. So as we know that whenever one object would be rolling over the surface of another object, so friction produced between the surface of two objects will be less. However, it will be resisting the motion, but it will be less. Okay, na? Its magnitude is lesser than that of sliding friction and also lesser than that of static friction. Getting it, guys? That is a basic
Yes,
thing
sir.
all of you have learned. Okay. Furthermore, we know that wheels are basically the circulating objects that are moving about a fixed point. Right now, this is the fixed point about which the wheels of an object would be moving. So this is basically imagine this wheel to be a circle, and this is the center of the circle. Okay, na? And there's a fixed radius about which the wheel will be moving. Right now, that is the radius. Okay. By the way, I have one question. Like, what do we call the longest radius? Not the longest radius. I mean to say, what do we call the longest chord of a circle?
Diameter.
Very good. Longest chord of a circle is called as diameter. Good. You guys have learned about concepts like secant. What is secant? Major secant, minor secant, segment, minor segment, major segment. Okay, I guess you would be learning about that in the 9th standard. So what we are saying that wheels move about a fixed center point. Okay. Now the wheels allows an object to roll over a surface rather than sliding that object. So say that this is the wheel of a car, for example. Okay, now think of this as a car. So the wheel of this car would be allowing the car to roll over the surface of the road rather than sliding. So it is rolling over the surface of the road. So thereby the friction is reduced here. So this results in less friction, and hence less energy will be required for the movement of the car on the road. So their rolling friction is used. Furthermore, you know that this rolling friction will be used in the wheels also. Now, you know about how the wheels are connected to the axle right now. And at the axle now, this ball bearings are fitted. Getting it? So this is the wheel and this is an axle. Okay. And over here, the ball bearings are fitted right now. So as the vehicle would be moving, so thereby these balls will also start to move. And we have to put grease in between them. In order to reduce the friction, grease is put in between the empty spaces between these balls. Okay. So here what we have learned that the sliding friction is being removed with the help of with the it is being replaced with the rolling friction. So thereby what happens that friction is reduced, and the heat will not be produced right now. Like if it were to be a sliding friction, ever seen this thing, like whenever a driver would be suddenly applying the brake, so thereby from rolling friction in the vehicle changes to sliding friction for a few minutes or few seconds. Getting it? And due to that, immediately lots of heat would be produced, and smoke will start to come out of the tire. Getting it? What I'm trying to say? Whenever a driver suddenly applies a brake, so then initially earlier it was it was a rolling friction, but immediately it changed to sliding friction as the car would slide for few seconds. Right now, as the car would be sliding for a few seconds, so thereby the wheels would experience sliding friction. It will go through sliding friction, and as we know, sliding friction is much more than the rolling friction. Hence, as a result of that, heat will be produced, and smoke will also be produced coming out of the tires of the vehicles. So, hope that concept is clear so far to everyone.
Yes.
Right? So the use of wheels or use of ball bearings in the vehicles, it reduces the friction. So as friction is reduced, so thereby less amount of heat will be produced. So if less amount of heat is produced, so thereby there will be less wear and tear of the mechanical parts of the vehicle. Got this now? So that is the concept of use of use of ball bearings and wheels in the vehicles. Okay. What other ways we have learned about? Polishing the surface, right? Polishing the
Yes, sir.
surface. Okay. Were there any other ways? Yes. Polishing the surface, use of ball bearings, use of wheels, or applying lubricants. Getting it, guys? So these are the ways. Apart from this, by reducing the weight also, the friction can be reduced, isn't it, guys? By reducing the weight, or also by reducing the force. Reducing the force with which two objects would be pressed against each other. So all these are the different ways using by which we can reduce the friction between the surface of two objects. Hope so far it is clear to everyone. Okay, now if there's any doubt in it, please let me know. Okay. Also, the reason why like how oil or grease basically works now, like oil and grease will go in between these irregular surface. It will fill up those irregular surfaces and thereby make the surface smoother. Right now, so kind of they are reducing the irregularities between the surface. Right now, that is one thing. Okay. Also keep this in mind that there hardly is any situation where the friction between the objects will be zero. There will always some amount some irregularities will exist between the surface of the objects. It's not like you can reduce the friction to zero. Okay, no? So keep this thing in mind, that an important thing to be noted down is that friction can never be reduced to zero. Why? Because there will always be some irregularities existing between the surface of the objects. So hope that concept is clear. If anyone has any questions, please let me know. Yes. If anyone has any questions, guys, please let me know.
No, sir. No doubts.
Okay, then. Now let us learn about the fluid friction. I think we just had a small idea about the fluid friction in the previous class, right? So you guys tell me regarding a fluid friction, where will fluid friction, I mean, in which objects fluid friction happens? Yes. The case
Sir,
of
can you
fluid,
repeat your question?
the question is that as in the previous class we did learned a little bit about the fluid friction, right? So do tell me, where will this fluid friction come into action? In which kind of objects it will be taking place? In which medium it will be taking place? I mean to say that. In the air and water. Okay, now in the gaseous and the liquid medium, fluid friction will come into action. Okay, now. So look at the direction of the object or the person in this image. It is in this direction. Getting it? And thereby, fluid friction will be acting in the opposite direction, in this direction. That is fluid friction. And when, as we learned in the previous class, when fluid friction is taking place in the case of liquids, so there it is also called as viscous friction. Okay, now keep that in mind. So it will be opposing the direction, opposing the movement of the object over it. Hope that is clear so far. Furthermore, fluid friction will be observed in the case of air also, right? So that will also be one such example. One another type of fluid friction. So like a person will be swimming in the water, as you see over here. A plane that would be flying through the air, it will experience fluid friction. Or, for example, a ship that is sailing on the water, that will also experience the friction force. Getting it, guys? So all of them would be experiencing the friction force. This is the direction of the motion, and this will be the direction of the fluid friction. Can you guys think of some other examples of fluid friction? And think of what factors will affect the fluid friction, how much amount of fluid friction will be generated. Yes. I want you guys to think about this. Do tell me, like this ship, let us consider two situations. In the first situation, the flood is, this ship is floating in the water. And in the second situation, let us think that this ship is floating over a very viscous liquid. Let us take example of, let us take, we can take example of oil, for example. Let us take example of oil. Okay. So you guys think about this. In which case the friction experienced by the ship will be more? On water or on oil? Yes.
So water.
Okay, what others have to say?
So can you repeat the question?
The question is that a ship is floating on water. In another situation, it is floating in oil. In which case fluid friction will be more?
Sir, water.
Everyone saying water?
So,
Oil. Okay, okay. Like, but we have to think about the reason behind our answers also, no?
so because oil is denser than water.
Oil is not denser than water. Oil is,
It's more lighter than water. So like
yeah,
it basically.
Oil is less denser than water, and oil will float. Oil floats above the water, no, basically.
Yes,
So
sir.
right now, water is more denser than it. Right now, okay. So considering the situation that both of them are having different density, but there's another concept also, like both of them have different viscosity. Getting it? What I'm trying to say? Both of them have got different viscosity. Getting it? So viscosity is a concept now. Like, for example, honey, and take example of water. Say, for example, you have 1 liter of honey in a jar of bottle, in a glass bottle, and you have 1 liter of honey, and in another one you have 1 liter of water. You have honey and you have water, for example. So you would have observed, like if you were to throw the honey on ground and throw water on the ground, Which one of them will be flowing very smoothly?
Water.
Water.
Water. It will flow smoothly and will spread over a large area. Getting it? Why? Because it has less viscosity as compared to the honey. Honey has high viscosity. Getting it now? It has high viscosity. So you can get a little bit idea about what the viscosity is now. Right now, like a given fluid or given liquid will be kind of resisting the motion, resisting the movement. So it will be fluid having high viscosity will be moving at a slower rate. Right now, a fluid having less viscosity will be moving at a faster rate. So the viscosity of the liquid will also determine the amount of fluid friction generated. Got this what I'm trying to say? So thereby, now let us replace the oil with honey, because there are some other things to be considered when we discuss about oil. Okay, now like bind force and several other concepts have to be included. So for the sake of convenience, let us take example of honey. Honey has higher viscosity, water has less viscosity. So if the ship, let us assume in an imaginary situation, if it were to be floating on the honey, so it will experience more resistance now while floating on the honey. Will it be easier to sail through the ocean of honey?
No.
No. Why? Because it has higher viscosity. So if the viscosity of the liquid is higher, so fluid friction generated will be higher. Getting it, everyone, what I'm trying to say?
Yes, sir.
Okay, now. So that is one thing. Getting it now. Okay. Now there are some other things also that determines it. Like particularly what happens now if the temperature, like in the summer season, the temperature of the water body in the ocean increases, right? So in that case, the viscosity of liquids will be decreasing. The viscosity of the liquid would be decreasing. So if the viscosity decreases, so fluid friction will also decrease. So let me just sum up the different things what we have learned so far. First of all, talking about the fluid friction. So talking about the fluid friction, we learned that basically the amount or the frictional force, generated on an object when it moves through a fluid. Basically, we are referring to air and liquid in this case. Okay, so first of all, we were learning about the case of water, where the fluid friction is also called as viscous friction, in general also called as viscous friction. So there we learned that there are a number of factors that will determine the amount of frictional force generated. Getting it now? Like the first thing is that you tell me if the speed of the swimmer were to be more, so will he not experience more fluid friction? The speed with which the swimmer is moving in the water body, if his or her speed is more, so thereby the fluid friction will increase. So talking about factors determining the fluid friction. So they are as follows. The first thing is speed of the object or the person. Okay, no? So if the object is moving with a higher speed, whether in water or whether in air, let us take both of them together, whether in water or whether in air, so thereby the fluid friction generated will be more. So that is one thing which you have understood, I think, right? Furthermore, another thing will be the viscosity of the fluid. Viscosity of liquid, basically we can take over here, right now. So viscosity is basically it's kind of the resistance a liquid will be offering against movement. Like basically its tendency to resist the flow. Right now, its tendency to resist the flow, to resist the movement. Is the concept of viscosity clear to everyone?
So can you explain it again?
Mhm. See, viscosity is now basically it's a tendency of a given fluid to resist its movement. Right now, like we had the example of honey and water. Honey does not move very fast, so it is offering some resistance to movement. It has some tendency to oppose its movement. Well, water will also have some tendency to oppose its movement, but it will be having less tendency. The viscosity is basically defined as the ability or the tendency of a given fluid to resist its movement. So hope you guys are able to grasp this concept, huh? Getting it,
Yes, sir.
Khadija? Right now? So honey has high viscosity, water has less viscosity. Like that, you can understand. Oil will have a kind of medium viscosity in between water and honey. Okay, so it's the tendency of a fluid to resist the flow, to resist the flow. So for example, in the case of water, the viscosity will be low. So if the viscosity is low, so thereby what will happen? The fluid friction will be low, no? So in water, it offers low viscosity, so less fluid friction is generated. Are you guys able to grasp this concept, everyone? While the viscosity will be medium viscosity. So medium fluid friction. I'm writing in short, okay, now there isn't much space over here. But in the case of honey, you guys tell me the viscosity will be higher, no? So high viscosity, so thereby fluid friction will also be high, isn't it? So
Yes, sir.
high fluid friction. So hope this concept is clear. So this was the another factor. Furthermore, the friction experienced by an object moving through air or moving through any given liquid will depend upon its shape also. Right? Will depend upon the shape also. But before that, there was one more thing. I was actually discussing about the temperature also. So the temperature also determines. How does it so? Try to understand. Like in the summer season, what happens now? In summer season, the temperature is high. So due to that, the ocean water warms up. Ocean water, it warms up, and that decreases the viscosity of the water. What it does? Decreases viscosity. Right now. So if viscosity is decreased, so thereby fluid friction will also be decreased. Fluid friction reduces. Opposite will happen in the case of winters now. Say if the water is frozen. So will the water flow? The viscosity will be higher or low? Tell me. In the winters, higher. So due to low temperature, what happens? Water, let us say, freezes. See, water freezes, thereby high viscosity. Viscosity will increase. And due to that, fluid friction is going to increase or decrease. More friction.
Increase.
Exactly. So fluid friction will be increased. So thereby icebreakers have to be used. You ever seen like when a ship moves through ice water, so it has to use ice breakers. Getting it, guys? So the icebreakers would be used in the ships in order to break the ice so that the ships can move properly. Okay, now. So hope you guys have understood. There are particular some special ships are there. They are specially designed in for the purpose of breaking down the ice. Getting it? That are called as
Yes, sir.
ship breakers. That is another concept. There was one more thing I was telling you about the shape of the object. So shape of object also determines it. So an object having a streamlined shape will experience less friction, right? Like you have in nature, like fishes are there, then we make aircrafts having a streamlined shape. So that is the case. So all these are the factors that will determine how much of fluid friction will be. So if there's any confusion left in this, please let me know. Also, the fluid friction, it comprises internal and external friction. So what does this concept mean? So talking about the internal friction. Okay, now see, moments ago we have learned about viscosity. So this is related to that. So see, for example, you have a liquid in a jar, for example. There are molecules of this. Let us take example of water. So these are the molecules of water, for example, right? And the molecules of the water, as we know, they are in constant motion. Although we don't get to see them moving, but they are in constant motion. They would be moving here and there. All if you know this basic thing, right? So due to the motion of these molecules, movement of the molecules of the water, friction will be generated between them. Isn't it, guys? Friction is generated, right?
Yes, sir.
So what is happening? Due to movement of molecules of water, for instance, friction is produced. Okay, friction is produced right now. Furthermore, this is an internal friction. It is happening inside the water, right? Internal friction. Now you guys tell me, if the movement of the given molecule, given the liquid is more, if the movement of the molecules of a given liquid is more, so the viscosity will be more or less? It will be actually
More?
less actually. Okay, no, it will be less. Getting it what I'm trying to say?
Yes, sir.
The movement of the molecules of a given liquid will determine its viscosity. So the viscosity will depend upon the movement of the molecules, or we can say will depend upon the internal friction. While in another situation, take the example of the honey. So the molecules of the honey, they will be showing more movement than the molecules of water, or will show less movement.
More.
Think again. This is example of, let us say, honey. We have taken honey in a jar. So the molecules of honey, they will be showing more movement or less movement.
Less.
Less.
Okay, na? So molecules of honey have less movement. They show less movement. So since they are showing less movement, so due to that, the friction generated, internal friction will be less or high?
Less.
Less. Very good. So less internal friction is there. Now what we have learned about honey, that it is a highly viscous liquid. It has high viscosity. While what we learned about water, it has low viscosity. Getting it, guys? So aren't the internal friction and the viscosity inversely related to each other? Like high internal friction, if a liquid has high internal friction, so viscosity is low. If the internal friction is less, viscosity is higher. So both of them are having an inverse relation. Getting it, all of you? right?
Yes, sir.
So that was the case of internal friction. But fluid friction comprises external friction also, no? So external friction in the fluid will be the force that the fluid will exert over another object when it will be flowing through another object. Getting it what I'm trying to say? Like as the honey would move on the ground, as let us say you have taken honey in a jar and that honey is flowing on the ground. So the between honey and the surface of the ground, some friction will be generated, right? This is honey and this is the ground. So in between that also friction will be generated, isn't it, guys? Right? So it is due to the movement of the fluid on a given object. What happens? A friction will be generated. So external friction in fluids is the force exerted by the fluid on the object over which it will be flowing. So that is the case of fluid friction, like water flowing on the ground. So between the surface of the ground and water, external friction will exist, or between the surface of the honey, between the honey and the ground, external friction will happen. So when we talk about fluid friction, we have to talk about both the internal and external friction. So hope this concept is clear to everyone. Yes.
Yes, sir.
Everyone got this now. Chakrika, Alif, Gauri, Khadija.
Yes.
Sir.
Furthermore, Alif, please read the given paragraph.
As an object travels in a fluid, it loses its energy in order to overcome the fluid friction. Hence, things that can easily flow in fluid have special shapes.
Like for example, you have birds, fishes are there, or aircrafts. So all of them have to overcome the fluid friction in order to move through it. And they utilize some energy while moving through the water, through the air, right now. So an object or an animal have to overcome the fluid friction. They have to overcome the fluid friction. In doing so, they have to apply some energy, use some energy for movement, right now. So they will be able, so in order to move easily through the medium, through the given liquid or air, so they have special shapes. Like the fishes, birds, or aircrafts, they all have streamlined shapes, right now. Or ships and boats, they also have a streamlined shape. Getting it now? That is one thing. Okay, you guys tell me this thing, like what are the adaptations in the birds that helps them to fly? What adaptations in birds helps them to fly?
Sir, their shape.
Their shape, first of all, good, right? And their bones are hollow inside, right? Now their bones are hollow. So if their bones are hollow, so the weight is reduced. They are lightweight, right now. So the weight of the bird is reduced because of hollow bones. They have a streamlined body, right now. Furthermore, we know that the forelimb of the birds, they are modified into wings, right now. The forelimbs of the birds are modified into wings. Getting it? So that helps them in movement, helps them in taking a flight and coming down on the ground. Their feathers are also very light and smooth, right? And there are spaces between the feathers which can trap the air. Getting it now? So thereby helps in reducing the body weight further. Anyways, so here basically we have completed the chapter. There are a few things left to be discussed. Okay, now few important things, few case studies which is left to be discussed, which we would be doing in the next class. Okay, now some case studies, some case-based questions we'll be learning in the next class. So if you guys have any other questions from this chapter, from any specific topic, please let me know. from friction, from different lubrications, I mean to say like different types of frictions, like a rolling friction, a static friction, or sliding friction, which we have learned about. Yes.
Sir, I have a doubt in what are the causes of friction.
Okay. Causes of friction. Okay.
Yes,
See,
sir.
talking about the cause of the friction, the main cause of the friction is the roughness of the surface. No surface is 100% smooth. So there will always be some friction between two objects. Okay, now, so the main cause of friction is roughness of the surface. So when we look very close to the surface of the objects, like taking help of a magnifying glass, so you will observe that the surfaces of the objects, although from distance, it will look very smooth. But when you look at it using a magnifying glass, so we find that it is actually having some irregularities between them. Now, if I were to zoom it further, whenever this object A would be moved above the object B, so look over here, what will happen now? These irregularities, irregular surface will kind of interlock into each other. It is like this. It is like this. It will interlock into each other. So thereby it will resist the movement. It will resist the movement of the object. Getting it now? So surface roughness is one of the main cause, right now. Furthermore, there's one more concept, like in higher classes you will understand. But still, let me tell you, like whenever two objects are kept in close contact for too long, so the molecules start sticking with each other. Right now, what happens? There's a force called as molecular adhesive force also. Molecular adhesive force. Ever happened this, like for example, you have a really thin blade, for example. Say, for example, we have a razor blade, for example. Okay, na? A razor blade. If it were to fall on the floor, on the tile surface, on a tile, for example, it will be really difficult sometimes to pick it up from the ground. Yeah, getting it. There, what happens? Sometimes what happens? All the space between the two, all the air between the two space has been replaced. Say, for example, I were to take two objects, this object A and this object B, and they have come with contact in such a manner that all the air between them has been removed. All the air gets removed. Getting it, guys? So if all the air between them gets kind of removed, so that will also kind of create a adhesive force between the objects. That also leads to friction further. Okay, so guys, another class is about to begin. Okay, now keep your doubts, and your doubts will